Hi, welcome to another interesting video of our channel. So this time we covered a very famous and very interesting event streaming platform tool called Kafka. So after watching all the videos, you will be able to learn what is Kafka, why we need Kafka, with addressing some real life problem statement, what are the basic components and the fundamental of Kafka. Especially here we have covered the architectural overview. Then you will be able to learn how to implement Kafka in your local system, and finally you will be able to learn that how we can implement the Kafka programmatically. So for programmatical implementation we have used Kafka client library along with the language called Java. So I hope you will find it really useful. So let's get started.
So what is Kafka, right? So Kafka nowadays a very essential skill to learn, right? Especially if you know that in the modern day approach or modern day applications, we actually deals with a million, a billion of data, and that is also basically depends on couple of consumers, correct? So there, Kafka can actually play a very crucial role in terms of satisfying those needs, right? So specifically, as we are talking from the very basic level, so first we will just try to see what exactly the Kafka from the definition or technical description perspective, but I'm sure that that can create some confusions. So after that, we will actually try to come up with some real life examples, maybe the problem statement through which we can actually understand that what exactly the area where Kafka can help us. And gradually we try to get into the more information that what exactly the Kafka does and how can what type of problems that Kafka could resolve, right? But before that, let's get into the Kafka's official site. So we will come to this whiteboard later on. So first of all, if you see, this is kafka.apache.com. This is the official site, and if you open it, so you could see that technical terminology or technical description wise, what is Kafka is. So Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipeline streaming, analytics, data integration, and mission critical applications, right folks? So these are like sounds very heavy words, isn't it? So we will try to cover each and everything, that why it is like what is like distributed and what is like event streaming and all those things, but just for an overall view, right? So if you see that in today's date, till today, that out of 10 manufacturing industries, 10 or out of 10 manufacturing industries where Kafka is being used. Similarly, for banks, the count is really like high. For insurance, also insurance domain-based companies, also Kafka is being used, and same for telecom industries, right? So if you see these counts, right? So what exactly does it mean? It basically means that how important to know about Kafka, right? In the today's world as part of the software development, right? So let's get into the whiteboard, which we already opened previously. So here I just prepared one very like basic type of example so that we can actually get into more details that where the Kafka can help us. And that's the reason first we need to know is why Kafka. That means like what exactly the problem this Kafka is actually addressing and why we should learn or we should use it. So let's take a very basic example, folks, right? So first, you know, right? Well, now it is. Let's say this is an online cab service, and as like this is very common nowadays, right? Each one of us, or most of us, at least one at a time, right? We may like use the online cab services nowadays. There are online bike services also, but both are like cab and bikes. That is also kind of a bike taxi, so those are like kind of work on a similar type of principle. So what is exactly happens? So for the time being, just forget about the technical things and all those things. If you try to think from the very basics, right, from the a normal consumer perspective. So once there is a online cab service, and we may have some kind of a application, that mobile application. So if I just write like mobile app, mobile app maybe, and what exactly the user does through this mobile app. So user basically try to look for some cabs, right? They open it, and what exactly the online cab service does is, so first it will search for the available cabs, right? If I just try to highlight it, so first is try to maybe this color, yeah, so first is try to locate the driver or the nearby available cabs. So once the driver is basically confirmed your cab request, then there is an option called or there is a feature called, I could say, like location tracking, right? Which is very a good feature, I would say, right? So we can actually determine, like, or we can actually see where my cab is right now, right? So it's kind of a real-time location information along with the timings we are getting into our app. And similarly, once maybe our ride is ended up, the fare calculation also happens, right? So if you see that, these are the features, right? And these things from a normal like consumer perspective, we already aware of, isn't it? Now slowly come to the engineering part of it, right? So let's say we wanted to develop this kind of a service, correct? Then what could be our approach with the current mindset, right? So current mindset, we don't know about the Kafka and all. So what could be the solution, or what could be the approach that we can follow to develop this kind of a setup? So what we can do is, maybe these are the services that we have, right? These are the services, these are the multiple services we have. And what we can do is, probably we need to upload this information into some database, isn't it? Into some database, and this database may be hosted in some server. Why we need to like we need to upload this information to database? Because obviously, in terms of producing this information to our consumers, we need the details, right? Let's say consumers, maybe you can, for the time being, we can consider that one of the user, maybe for the time being I'm considering only one user at my platform, and that user is actually using some mobile device. And this information I need to, whatever my cab is basically generating, right? This information I need to provide to my consumer. The another consumer can be, maybe this is another consumer, and this consumer maybe the analytics. And it is nowadays very popular, as we know, right? Like we need to generate the trends of our cab, or maybe to advertise the people, right? Or maybe see other services, to provide the other type of service. Analytics is very much important. So not only, so this is one of the consumers where our end user are getting the information, and there could be another consumer where we would like to produce the information, could be our this analytics service, right? So far this is clear. Now let's try to get into a more complexity, right? So let's say I have one more, or maybe few more consumers now, okay? And each and every consumers, they wanted to get the cab information, right? Right, that's what happens in the real life scenario, right? So let's say probably my online cab service getting popular, it got popularities, and I am planning to scale up my business. So what could happen, like now I need to extend it, right? So now I need to extend it. So initially it was only one state, and now it is like being expanded, maybe 10 more states. So in the 10 more states, maybe each state, probably I have around 1000 or 1k or 1000 of cabs operationable, operating on cabs are there. And 1000 that multiplied by 10, so 1000 multiplied by 10. So these many cabs producing data. Sounds a bit interesting now. So initially what we have seen, that we have developed one application which are kind of looks like this, very basic architecture or like solution, and we are trying to hit the database each and every time to getting the details, and gradually we are good with that. But once my business has been scaled up, maybe it's expanded into 10 more states, and each state's having 1,000 of cabs, right? 1,000 of cab and cab drivers and so many of users, consumers of it. So 1,000 into 10, these many cabs are producing the data. Now just think from that perspective, like how much data I need to handle, right? So for our understanding perspective, if I wanted to make it more simpler, let's not target maybe three features that whatever we're talking about. Let's at least take one of the service and try to find out, at least to manage one of the service with this approach, what could be the complexity we could have, or what could be the issue that we could found. The feature that I'm targeting to explain is location tracking, right? So what the location tracking, what exactly happening in the location tracking part? So let's say I am like, this is my one point, like point A, and this is my another point which is like point B. Okay, so I can consider like this is the maybe me as an like as an rider, and this is the cab, right? This is the cab along with driver, right? So I sent a book request. My online cab service is actually okay, fine. Okay, this is where the cab is available, maybe nearby me. And now this driver already accepted my request. The normal flow goes on. So what could happen now? So once the cab started from this location, so it is like the path is like this. Okay, the path is like this. So this is the path that the cab should follow to reach to my location, my current location. And now from the cab location tracking perspective, we know that from each and every location we are actually can get the real-time information about the cab. So these are the like dot points I'm just highlighting just to provide the location timing. So let's say my first cab probably started from here at 10 a.m. morning, and it's like keep on getting, like maybe this is 10 a.m. and maybe this is at 10:20 a.m. This is the location the cab was there. Maybe here cab reach around 10:30 a.m. 10:30 a.m. and finally so many, so I'm just skipping the other timestamps, and finally it could reach me around 11 a.m. right? So if you try to open the respective app, so I just have provided maybe 10 minutes or 10 minutes delay here in the example, but it is like more real time, right? You can also track maybe second by second where your cab is actually there, the specific location. Now let's say I wanted to upload this information into my database. So let's say I'm considering this is my DB, and here whatever the table, maybe the location table I am having, location table, and this in this location table I wanted to save the location. One information is location and another information is time. So now think from that perspective, maybe I wanted to save the first data, maybe location 1 or location A, along with the time is like 10 a.m. right? Similarly, if I just wanted to save the another location, so I again maybe the location is same, location A, and maybe 10:01 a.m. and so on. So now you can see that maybe the timings are like keep on increasing based on the seconds now, isn't it, right? So if I keep on wanted to add the location information to the specific DB on a every second basis, so what could happen, right? There is a high chance my DB can slows down or maybe get into the crash, right? Why? Now the question is why? Because there is a concept called throughput, okay? And for db it is low, okay? So for database, the throughput is low. What is a throughput? So throughput you can consider from that perspective that per unit time, whatever the data we can actually get right or maybe access from the database, that is called throughput, right? So for the case of database, the throughput is very low. That is the reason if we wanted to capture this kind of real-time information, folks, this is very important term, real-time information, right? And we just wanted to capture, or we just wanted to handle this entire real-time information with the database, it's going to be very difficult and problematic, and sometimes and obviously it could happen like in one time your database may not respond. That means what? Your entire app going to be like crash. There is no use, because this location tracking for the time being, maybe we just for an example perspective, we consider maybe one user at a time. What could happen, like there are, we said, like 10 state 1,000 cabs, maybe 1,000, maybe millions of users, they wanted to get their respective location details or cab or driver information in the same time, in the real time as well. It is not like after 10 minutes my cab reached to me and then I'm sending the location information of 10:30 a.m. that where my cab is currently. So that is not the visible feasible case, right? So here, to solve this throughput or this huge requirement of real-time information, Kafka comes to the picture. Kafka comes to the picture. So now if you just try to tell me, right, from this discussion, one of the factor that we could understand that for low throughput, this type of scenarios handling is very much difficult. That means Kafka is having high throughput. Okay, Kafka is having high throughput, right? So that's the reason, like if we try to introduce a Kafka instance over here and then try to write our specific information or put our specific information into the DB, the things going to be very smooth and also real time. Now here is one question. Then why we still relying on the database, right? Database in the sense like SQL database maybe, or PostgreSQL, anything. Then why we still like depends or relying on the database? Why we still consider a database for our development? Why don't we just simply replace the database along with Kafka, right? Then our whole problem solves, right? But we cannot do it. Why? Because the Kafka, the each and everything, right? They have their own like pros and cons. From this discussion, we got to know that database is having low throughput where Kafka is having high throughput. But from the storage perspective, database having the high storage capability where Kafka is also having the storage capability, but that is like kind of a temporary, right? And compared to the database, it is low. But we know, right, to handle or the data and to store perspective and to be available with the system, we need a solution where we can make or we can store the data for a long time. That is the reason we cannot just remove the factor of database from our development or architectural plan, right? So we need both of the things. So we need database, we need, as well as we need the Kafka. Make sense? So similarly, with this like relative problem, we can also take, or we can also discuss one more like real life example, that is like e-commerce platform. We all are using it nowadays, very common. So I'm just taking maybe 2-3 features out of it. So let's say there is a mobile item. So I can say that mobile phone. This is one of the product that is being available in some online e-commerce platform. So for the understanding perspective, I'm writing like e-com platform. Okay, so in the e-com platform, one mobile phone is available, and I'm just planning to purchase it. So what could happen if you see one mobile phone, right? So from the very standard point of view, what are the details that we can see on the mobile phone? So mobile phone can have like, so I'm just writing as well. So let's say this mobile code is having this type of informations. So at least 2-3 information we can actually gather for our understanding perspective. So let's say this mobile phone is having a unique product code, something like this. This mobile phone is having the price information, right? Price info. And this mobile phone is also having the quantity info, right? Because there is an option, right? Like how many, what is the count that you would like to place the order. It can be one mobile phone or multiple, more than one mobile phones, right? So these are the information, very basic three information for the time being we are considering that we can have from a mobile phone service. Let's say I'm considering from the technical perspective that mobile phone, which is nothing but an item. Maybe item is one of the service that we have, and this service is having this many details: product code, price information, quantity information. Makes sense? And so now again go back to the your normal thought process, where we already just assuming that we are on some online platform, and then e-commerce platform, and then we are trying to order one mobile phone. So initial from our usual behavior, what we are exactly doing there. So once we finalize that this is the mobile phone we need to purchase, first what we are doing is we are clicking on the add to cart button, right? And then initially, like usually, the browser or this application take us to the checkout page. So I am taking one specific section and mentioning it here like cart and checkout. So I can say that this is one of the service that we need to perform. That this is the one of this I can like this is the one of the service which can help us to proceed ahead. So once my cart and checkout done, what is the next step that is coming? Payment service, the payment part. So I can say that payment is another service. And let's say my payment is done. So after that, my order is being placed. And after like placing the order, what exactly we are seeing is like where is my order now? Like we can track the order. Sometimes we can cancel the order, isn't it? So the to address those kind of things, we may have one another service or one more service called order service, right? So now again from the engineering perspective, if you think, so this is one of the item service which is being producing this type of information like product code, price information, and quantity information we are getting from out of here. And these are the dependent services which requires this information. Cart and checkout requires maybe product code and price and quantity, these three informations. So these three information, this cart and checkout may require, right? These three information, and similarly for others as well, right? And similarly for others as well, these three information required. Similarly, payment service also required these three information to calculate the actual price or what exactly user need to pay for it. And order service also required maybe the product code only to track the order. Okay. And here also we can actually use Kafka as a solution. And moreover, this is something called, like if you think from the perspective like microservice architecture, right? Because if you see that each and every things we actually said like a small services. And in the microservice architecture, like all like couple of small services can be integrated to each other and finally uh, can support to a large system, right? So e-commerce platform is not a like small system; it's a huge platform, isn't it? So here also, where item service, if I say that item service is one of the section for the time being, I'm just targeting, or I'm just saying those things as a sections or service, but gradually we will also learn about couple of terminology which is associated with the Kafka. So this is one of the service which is being producing couple of, I can say, like data or information for the time being, and that data, then that and those data, on those data these other services are dependent, right? And this data has to be real time, right? Because you are on the e-commerce platform, so like you or like me, there are like millions of people who are targeting to purchase the mobile phone, the same mobile phone, maybe some big billion day or this kind of days are running on, where most of the time like discounts are there, right? So the traffic is huge, so there are so many people around the globe, they wanted to purchase this mobile. And that is also real time, because if that is not a real time, then your cart and checkout may fail, your payment may fail, your order tracking may fail, right? So again, the use case kind of a similar, just like your online cab service, only the way that how it is doing, that is different, but still it is also required a real time information. And we can also think of a solution like Kafka to be introduced here to manage the real-time information and produce and the data, and then manage the data, and finally provide the respective data to the respective service containers. Okay. So, and similarly, probably after watching these specific examples, you can also think of couple of more examples where you can actually introduce Kafka by your own. We discussed here two examples. One is online cab service, and second one is the e-commerce platform. Maybe something like that you can also think of, so that understanding going to be very clear, right? Just like the food delivery apps, right? Nowadays it is also using the same type of concept, where real-time information has to be produced and be consumed. Okay. So I hope with these discussions, our thought process now at least improved a bit, and we at least get to know that what exactly the problem, or what is the area where we should go ahead with the solution called Kafka, right? Okay. So yeah, so that's it for this discussion. Later on, we will see that from the Kafka perspective, what are the components and what are the implementation of Kafka. Now, we will talk about the Kafka fundamentals, and also we will see that what are the major components that Kafka contains, right? So far, what exactly the example we discussed so far, right? So let's just have some diagram and then we can elaborate. So let's say we basically talked about one car application, and we said that this car online car booking application basically, and this is basically producing some kind of data or informations. Okay. So I'm just writing quickly. So probably this is like the speed info. This is some information, maybe the location, location, and also maybe the fare details. And finally, we said that ultimately our goal is to like this information has to go into the to get into the server. There is something like maybe this is the specific server, or may we could say that let's say not considered server, but maybe some other services, right? So this is maybe my analytics service, analytics to which I just wanted to have, or the analytics part, and some other mobile applications. Maybe this is some mobile some consumer is there, so they also getting the details in their specific mobile devices and so on, so like that. And we also mentioned that we also discussed that what are the disadvantage or drawbacks, we could say, if we just try to get the real time data and try to store it into the database, right? And we identified that the biggest issue is with like throughput, isn't it? Because we learned that the db has like the throughput of db is always low, whereas kafka is having the high throughput, right? So as part of this problem solution, we actually introduced Kafka in this specific scenario, right? In this specific scenario. So till that part, this has already been discussed, right? So let's say this is like car booking app, right? So till that part, this is already discussed. So now let's try to focus on this Kafka, that how exactly Kafka works internally. That is something we just wanted to know, right? So to do that, what I can do is we can just try to make some more diagrams, right? So first, folks, if you like see, right? So what exactly this app, if I consider this application, so what exactly this card app application does? This card app is application is actually providing some records, generating some informations, right? So in technical terms, this is, or this can be called as producing. So this card application basically producing some info. So what does this card application called? This card application can called as producer because it's producing some information, isn't it? So say for example, I'm just mentioning here that this is one of my producer. Okay, this is one of my producer. I'm just replicating like this. You can consider this is the specific car booking application. Okay, and now in between we introduced Kafka as part of our solution. So say for example, this is my Kafka instance, and also we already also described couple of mobile devices and couple of other services who are actually taking this information, whatever my car booking application is actually generating, right? So in technical terminology, this part we can mention as consumers. What you can say, that is called consumer, right? Very basic and very easy to understand concept. Producer, someone who is actually producing the information or something which is producing the information, and consumers, which are like basically consuming the respective informations. And how it is happening, it is happening via Kafka. So for the time being, just make this statement very clear, right? One part is consumer, one part is producer, one part is consumer. Producer is responsible to produce the data or information. Consumer is responsible to read or to fetch the data. And in between, Kafka is the kind of a middleman who is actually taking care of all these things, right? So now, obviously, things are not that much straightforward. Now we need to see that how Kafka is actually doing those things, right? So for understanding, we are just putting some arrow over there, and finally, from here, details are being consumed to the consumer, correct? So now, if I try to like highlight this specific portion, this is actually called Kafka cluster. Kafka cluster. So Kafka cluster, just you can remember like this, it's kind of a Kafka server. Okay. So basically Kafka producer responsibility is to write the data into Kafka cluster, and consumer responsibility is to read the data from the specific Kafka cluster. Right? Now, if we try to get more information about this specific Kafka, so to do that, what we can do is we can draw one more diagram specific for Kafka. This is my Kafka cluster for the time being. So I'm just denoting as like Kafka cluster here. Kafka cluster, let's say, and this Kafka cluster is having few components. Now the question is like, okay, till to that part we have understood that we have one producer, we have one consumer. Producer basically producing the data or maybe writing the data into the Kafka, and consumers are basically fetching out the data, and basically they're reading the data and then using for further process and whatever it's supposed to do. So how Kafka is actually maintaining the data, right? So inside the Kafka, we have few more segments like this. Say for example, this one, and this one. Okay, and these segments are known as broker. Broker. Okay. Now the question is, what is broker? So broker, folks, you can just correlate like this. It's kind of a local storage. It's kind of a storage where we can actually save our respective informations. Make sense? This kind of a storage. So when producer is actually producing the information and write down into Kafka cluster, it is actually selecting some broker, and then that information is actually being stored through the broker into the memory. If it is running on my specific local server, then it can be a local storage. So that is something known as like broker. Make sense? One Kafka cluster can have multiple brokers or broker instances. Okay. And so for the time being, we are only discussing maybe one or maybe one, two, and three, and so on. Okay. And what happens, like, okay, so the question is like, okay, that's the all the things, like, okay, here my producer is here, the producer is actually producing some informations. So and then it is goes down to the broker, and then whenever the consumers are there, so consumer are basically fetching the information from the broker. Is that the all the things? The answer is no. Within the broker also, the informations are getting segregated. Now we will try to expand the broker. Okay. So what we can do is we can take one more diagram over here, and we will try to highlight one specific broker. This is one specific broker for our understanding. Okay. For our understanding here, I am mentioning like broker, and let me just put it here. So now folks, very interesting part. A broker basically contains something called topic. Okay, so within that broker we have something called topic. So topics, so what basically topic does, so topics are nothing but the messages or the logs. Basically, now if I come to the technical part of it or technical terminology, if I mention the technical terminology of it, so whatever producer are being producing as part of the records, for our example, maybe producer are basically producing something like your cab speed info, and then your location info, and so on. Maybe these two, and we are just considering, right? This two type of informations that cap producer, this producer is actually producing. These are basically treated as logs or messages, right? So if you remember at the very beginning, as part of the Kafka technical description, we talked about something like streams or events, right? So this can also known as like some kind of messages or events that is Kafka is basically Kafka basically the producers are basically producing, right? And it is get stored within the topic. Okay. And now if I again introduced producer here, right? This is my, say for example, this is my producer, and I am also having one consumer, right? So basically like this, the producer is this one, and is the consumer, sorry for the very small arrow like this, right? Okay. So finally what's happening here?
So if this is my producer, and producer basically producing certain info, which is going first into this Kafka cluster, then it is Kafka cluster, and within the Kafka cluster some broker has been assigned, and after that within the broker the informations are getting stored into the topic, and finally it goes to the consumer. Okay, so I can just write like info, basically whatever the producer producing from here, it is getting stored over here. Correct. One some few points over here, that whenever producer produces some messages, right, or records where basically denotes as a message. So whenever producer producing some messages, that message is actually contains two parameter. One is key and value. Okay, this key and value pair, it is being stored, right? Now the question could be, okay, maybe I am implementing one Kafka and through in my programming, and then I may not handle this probably. Okay, so whatever my producer, so producer actually producing some record, but I may not have handled this, that whatever the messages I supposed to pass through the Kafka, that I supposed to define some keys of it. So in that case, what could happen? So in that case, Kafka automatically assigns some key to it. Okay, so now this is what we have seen as part of the broker and the topic. Now one more question it may like we can have in our mind, that first of all the very basic question is, as we have seen that one Kafka cluster can have multiple brokers. So is that something followed for topic as well? The answer is yes. So we can have multiple topics, right? We can have multiple topics within Kafka. Now, whenever we would like to consume certain records, we need to identify that through which topic we are actually willing to get the data. Correct? Now, the second question can be like, why we need multiple topics? So, if I just wanted to draw one more quick diagram over here, let's say this is my producer, this is my another producer. So, folks, we can have multiple producers as well. Okay? This is my another producer. We have in between a Kafka cluster over here, and I have maybe multiple consumers, right? Consumers also can be multiple, right? So maybe this producer is actually generating some kind of, you can say like cab details itself, like what type of cab it is, right? What is the number, what is the current speed rate of the cab. This producer is maybe producing the cab driver details, right? This producer may be producing the cab location details according to that, and simultaneously this consumer may responsible to generate the analytics. This consumer may generate may calculate the fare, and this consumer may be some a mobile app which is being consumed by some other application, just for an example, right? So what how it can be, so it can be like each and every producer going to write the records into the specific Kafka cluster, whatever we have defined so far, right? Sorry about that. uh, this like this, something happened with my cursor. Let me just try to uh, let me just try to remove this. Okay, so sorry. So I was having some trouble with the cursor. Anyways, so what I was talking about, like say for example, I have multiple producers, and these producers are producing the certain records, and that is goes into the my Kafka cluster, and I also have the multiple consumers, right? So what could happen, like
each and every consumers would like to get the records from the Kafka. Now, in such case, try to think from that perspective that if this is something happened and this is realistic actually, that's how Kafka works in projects. So if this type of situation I would like to handle, then how this consumer would know that what could be the specific area from where I can get the information of my location details, how this consumer would know that how what could be the specific area from where I could get maybe driver details of the cab, and so on. So topics are basically helping us to identify that from which portion of my specific broker or maybe the Kafka cluster, what type of records that I supposed to get as a consumer, right? So that's the reason we can have multiple topics as well. Say for example, these all are my topics, and I can just name for my understanding like T1. T1 is my first topic. T1 is my first topic, and then I'm just copying it. This could be my T2, and this could be my T3, right? And finally, let's say this specific consumer would like to consume the topic 1 data. This specific consumer would like to consume the topic 2 data, and this specific consumer would like to get the information from topic 3. So now it has been clear to the consumer that through which portion of the specific Kafka cluster and what type of data I would like to access from, like where, basically the identification. So through the topic we can actually identify. Makes sense why we have the multiple topic related concept over here, correct? Now try to get more like deep dive into the topic, right? So what exactly about topic? We said that topic is something which contain the messages or logs basically produced by producer within the Kafka cluster and within the broker. That's what we have understood, right? Now, if I just try to take out this topic in some other diagram and try to understand that how internally topic manages our informations or messages and how it looks like. Okay, so say for example, this is one of my topic. So we are within the Kafka cluster. So for our understanding, let's say I'm just making one more box over here. This is my topic, and I'm just writing over here like maybe topic 1, and this topic is there. And now we just would like to know that how one topic is actually managing our specific data or messages. So topics are basically a integral part of partitions. So now one more concept introduced, right? Partitions. Now the question is like, then what is partition? Till that part we understood like, okay, producer, consumer, Kafka cluster, broker, and the topic. Then one more thing comes up that is called partition. So partition also very interesting factor, folks, over here. So topics are basically distributed the specific messages or logs in the form of specific partitions, right? So it is something like within the each topic we have something called, say for example, this is small chunks over here. This is nothing but the partitions. Okay, let's say I'm just for our understanding purpose, this is P1, partition number 1. This can be like P2, this can be like P3, this is my P3, and finally this is my P4. Makes sense? We will understand that why again we need another layer. Again we need another layer which is called partitions. Now if we again try to drill down this specific partition,
and how partition basically works. So partitions again internally save our data like this. Let's say this is our memory. These are memory, and this is a certain portion of the memory, right? I just try to. This is the one. Many other cells that we are preparing here, or maybe one more cell. Just trying to draw and then the one. So within the partition, we have the record saved in the memory like this. And so now here I just wanted to tell one thing, that in like how the messages are being stored. So we have seen something called logs, right folks? Logs. So how we are writing the logs? Let's say this is one of my log file, and whenever I would like to write something within my log file, I always starts from here, right? Maybe something log I'm writing ABC. Then whenever I would like to write something new into the file, I always have to start from the end, isn't it? Like this and this. That means what? Like I'm always starting from at the end, because at the end of the message or end of the log only giving me the new space. So for partition and within the Kafka also, the messages are being stored like this format also. Let's say um, at the very first cell, we have some information. Maybe one of the information may be um, ABC. So this is already there. Now one more new information came up which I need to store. So where, in which place it gonna be stored? So in that case, the information going to be stored here. So it can be like DEF. Like that, the other things going to be followed. Like something like GH, and then your 123, something like this, or IJK, something like this, and so on, right? And each and every segments denotes with some number. So this can be like 0, this can be my 1, this can be the 2, this can be my 3, this can be 4, and so on. Probably, let's say it is like kind of infinite. Okay, so there are basically no such limit exist. Okay, so question can be, right, that okay, if I storing my specific messages or information in this manner and it is keep on saving like this, then until what number it goes? So there ideally no such numbers or index numbers are being defined. We can store as many records as we want. Now here folks, one more terminology, that whatever the numbering we mentioned here, right, like 0, 1, 2, 3, 4, these numbers are known as offset. Offset. Okay, that means what? So Kafka giving us this specific feature, that say for example, I'm accessing this specific topic, which is my topic 1, and within the topic 1, and there are a couple of partitions that been assigned that we got to know. And we also got to know that partitions are basically keeping our messages or specific logs in this manner. Now, if I would say, for example, I wanted to get the information which is there on the log here, like this, in this specific area, maybe in this specific area, right? So now how I can do it, right? So I can access this specific area of the information by defining the offset value, which is 3, right? So that's how Kafka is so much flexible as well, that you not only been able to store a huge number of records and being able to access earliest record of it, whatever being saved in the log file, but also you have the capability where you can define certain offset value and try to fetch the information to that value as well. Make sense? Now if I take one more white space, So far we just learned about the basic Kafka consumer, producer, consumer, broker, topic, and Kafka cluster. Okay. And now if one more thing I just wanted to mention, maybe if I just consider this one, this specific, um, yeah, this specific Kafka diagram. So there is something called zookeeper. Okay. So if I say this entire Kafka managed by something called zookeeper. Okay, so zookeeper's responsibility to manage the Kafka, manage the broker, and if any failures occur, then that is something is managed by zookeeper. So we literally do not like much bother about like how zookeeper handle it. And going forward, if we try to implement that, do you need to implement zookeeper as well or not? So the answer is no, because if we have the Kafka library with it, so Kafka internally implementing zookeeper as well. It's kind of a manager, you can say Kafka manager. So is basically handling the Kafka cluster itself, manages the Kafka cluster itself, and whatever the components we learn about the Kafka cluster, like your broker, your topic, your specific partition, and all those things, that is being managed by Zookeeper, right? Okay. So now some interesting fact, that is called rebalancing. Okay, that is called rebalancing. So as we got to know that Kafka is actually handled the complex distributed systems, right? And that's the reason, like if we need a specific records, especially the real-time records in terms of managing the distributed systems, then Kafka plays a very crucial role. Now there is a factor that it is called the rebalancing, or also known as like self-balancing. So instead of rebalancing, I can say that self-balancing. So what does it means? Okay. So far, folks, whatever we learned about the something called topics. So let's say if I draw one more diagram over here, let's say this is my expanded version of topic, and in this topic we have something called partitions. This is one of the partition. This is, say for example, total 5 partitions I have taken over here, like partition 0, 1, 2, and 3. Now we know that these specific topics are being consumed by whom? Being consumed by consumers. Being consumed by consumers. So if this is the case, then what could happen, like, so this is my topic, right? So I'm just writing over here so that we can have the clarity. This is my topic 1, and within this topic 1 we have the certain partitions. Now let's say I have only one consumer at this time. So I am just writing over here that this is my consumer. This is my consumer, right? Only one consumer I have. Now try to think that, okay, if only one consumer I am having and I am having 5 partitions in my topic, then from which partition this consumer going to get the records, right? So basically in this case, from this partition also, my consumer going to get the detail records. From this partition also, my consumer get the record. This partition also and this partition. So basically, from all the partitions, my consumers are actually getting the records. Right? That means what? Kafka is basically trying to self-balancing here. Okay? Now the question is, okay, we have understood this factor. Let's say I'm just removing these signs and try to make it a bit more tricky. Let's say I have one more consumer over here. It's a real time, because I just cannot expect that in the distributed system I may have only one consumer, right? I can have multiple consumers. This is one of the consumer, and Say for example, this is my another consumer, that is consumer 2. Now what could happen? Let's try to think of. So basically in this case, as part of the self-balancing feature, Kafka will try to assign like this. So first two partition going to provide the records or information to the consumer 1, and these two going to provide the information to the consumer 2. Self-balancing, self-balancing. Now, if we try to make it a bit more tricky, let's say I have introduced, first of all like this, let's say I have introduced one more consumer. This is my consumer 3. Consumer, consumer, let's say 3. Okay, makes sense. Now tell me, which partition going to provide information to this consumer 3? The answer is the consumer 3 going to be an idle consumer, because all of the partitions are already being occupied by other consumers as part of the self-balancing feature. Okay, so this consumer won't get any specific partition as part of the topic to get the information. So it sounds like a bit problematic, isn't it? Right? Because in real life scenario, this is a very basic use case, that your topic, one topic can be consumed by multiple services or multiple consumers. So to handle this kind of scenario, there is something called, or one more topic or one more concept that has been introduced, that is called consumer groups. So before like talking about consumer group, folks, we need to make sure that before this consumer groups, whatever the topic we already described, right? The basics of Kafka and the producer consumer topic and how topics have been managed, partitions and cell balancing, we just need to have a proper clarity, right? Otherwise, it would be sounds like a bit confusing. Now, in the consumer groups, what is the basic modification, I could say, that has been taken up so that this problem can be resolved? So again, if I just try to extend this Kafka topic, this is my topic, and my topic name is same. Let's say this is my topic name. So topic name is topic 1. And again, if I try to draw the same partitions, let's say I have total 4 partitions for the time being, right? And I have one consumer here and one and maybe 3, 4 consumers are here. Okay, but this time we will introduce one more section like this and like this, and this is something we will denote as CG-1 and CG-2. That means consumer group 1 and consumer group 2. That's for just for information, folks, that in Kafka, this consumer by default a part of Kafka consumer group. Even though if you are defined or not defined, it's going to be by default a part of some consumer groups, right? Now let's say we have defined our 2 consumer groups. One is CZ, like consumer group 1, and another one is consumer group 2. Make sense? Now how this like self-balancing could work? So for this case, for this consumer, right, for this specific consumer, this one going to provide the records here. Records will go like this as it is, right? And now the as per our previous understanding, we will say that okay, as we can see that all partitions are already been consumed by consumer one group, right? Consumer group 1. Then what about the consumer group 2? So here is the like interesting factor, folks. So as part of the consumer group 2, as we have defined our these four consumers within some consumer group 2, that means Kafka will treat as a specific consumer, and it will again provide the information as part of the self-balancing manner. Sounds very interesting, isn't it? So consumer group 1 we have, and that consumer group only contain one consumer, so it is eligible to get information from all the topics, as well as part of the consumer group 2, whatever the consumers I have, those consumer also being able to get all the information from the specific partitions, right? And this is something being handled by following one model, which is called pub sub. So Kafka is basically allocating this type of consumer and publisher model, which is being followed by pub sub, publisher and subscriber models. One more thing, that there is a one technical terminology associated with this. So we said that whenever we are defining some topic, or we would like to get the value from the Kafka, we need a topic, so that consumer can understand that on specific which record that it needs. So consumer has to tell to the specific topic that, hey topic, I would like to access you and I would like to get the information from you, so that consumer, so the topic could understand that I would like to emit the message to the consumers now. And this specific, like this specific thing, whatever, where consumers are basically telling to the topic that, so the topic would understand that I need to start sending the information, this is called subscribe, right? This is called subscribe. So consumer has to subscribe some topic, so this is called subscribe. So consumer has to subscribe to some topic, then only topic would understand that, okay, some consumer has subscribed on me and my responsibility to send or emit the specific information to the specific consumer, right? So currently if you are watching this, so maybe there is an subscribe option, right? So if you subscribe my video, so what would happen, like uh, YouTube will get to know that you are interested on this channel, so whenever any new updates are going to be there, so it will keep on, it will keep getting the notifications, something you can correlate like this. Okay, so consumers are basically subscribed to the specific topic, and based on that, topics are now understood, like, okay, now I need to send the specific information to this consumer as well, correct? So this is what very important and very interesting factor about Kafka. Now one more thing that we would learn, that is called replication factor. Replication factor. Okay. So now what is replication factor does? So folks, as so far we have understood that Kafka is something which is responsible to handle a huge number of data, right? And that is also, it is basically manage the entire record. So if this is my Kafka cluster, within the Kafka cluster, I have something called broker, right? I have something called broker. So it can be like multiple instances. And within the broker, I have something called topic, right? I have something called topic. So if I just need to write, so this is my Kafka cluster. This is my brokers. And within this, I have, this is my topic, and topic name I'm just providing like T1. Okay, so this is like an overall and very very basic type of diagram that we just understood so far. Now while handling that much of information, or that much of messages or logs, there is a chance, right, that maybe in some instance my one of the broker, maybe this one would get down. Could happen, maybe something happened, maybe it is not able to store the records, correct? Or maybe somehow the storage maybe crashed or something. I'm just taking very random examples. So for such case, if that is something happened, then what could be our catch? How Kafka handles this certain situation? That's the reason Kafka also follows replication factor. That means what? Whenever a consumer producing some information or writes some information into Kafka cluster, then and there Kafka automatically creates this replica. Kafka automatically creates its replica into multiple brokers. That means if this is my broker 1, say for example, this is my broker 1 and this is my broker 2, this is my broker 2, this is my B2. So in both of the brokers, Kafka could contain the same topic as a replication. Same topic as a replication. And at least in real life, Kafka at least replicate the same information 3 times. Replicate the same information 3 times. That means what? It's actually assuring us if something goes wrong with any of the broker or something goes happen wrong, our information won't get lost. We always being able to fetch the information. Now the question is like, if something happened, or maybe whenever producer producing some messages or logs or information into Kafka cluster, how Kafka would know that which broker is to select and how to make this replication factor? Is there something we would like to do? The answer is no. If you remember, we talk about zookeeper, right? So zookeeper is kind of playing a manager role, so managing whole the Kafka cluster. So zookeeper is actually taking the responsibility that whenever Kafka producing the messages or information, or sorry, whenever producer producing some messages or information and gets into the Kafka cluster, zookeeper will assign some broker and then and there it will create some replica of it. That means if something goes wrong, then your information or our information, whatever producer is basically produced, that is being safe. Okay, that is being safe. And as part of the replication factor, 2 more terminology are associated, which is called leaders and followers. So what is the leader and the follower? Say for example, this is the producer. This producer produced some info or some messages. Now it is being get into the Kafka cluster. Okay. So once it's gets into the Kafka cluster, some broker going to be assigned to that by our Kafka manager, say zookeeper. So whatever the broker at the very first has been assigned to keep the record, that is called leader. So say for example, for this case, this broker B1 is something or one of the broker which is being identified by the manager, our Kafka manager, and it is the first broker which is storing the information produced by the producer. So I can say this topic, say for example, this specific broker, that is B1, is my leader. And as part of the replication factor, Kafka will create the replica of this B1, right? And maybe 3 times the replica can be stored within the Kafka cluster. So other replicated broker can be known as followers. The follower's responsibility to replicate the information. Let's say once the leader and followers has been defined, producer now send some update
to the existing messages. So followers responsibility to follow the leader and get the information whatever the update has been made into the information and update their existing data as well. Okay, so this is the concept of leaders and followers. Make sense? Okay, so this is what about the Kafka fundamental, Kafka architecture, and the basic component of Kafka, right? Later we will see that how we can implement Kafka programmatically. So before get into the program implementation, the programmatical implementation of Kafka client, let's first try to see that how exactly Kafka works locally, right? So we understood the concept of Kafka, and we already understood that if producer produce some kind of a message or events, then how those messages are being consumed by consumers, right? So let's try to demonstrate that scenario or that use case locally, right? So to set up this local Kafka instance, I have prepared this GitHub gist documentation, which I will provide along with the description, so you can check out that link. So I will follow the mentioned step from here itself. So first of all, what we need to do is like we need to just run the or generate the cluster ID, Kafka cluster ID. So to do that, I will simply take this command and just copy this. I will open this instance, Ubuntu instance, whatever is running on my system, and I will execute the command. So you can see that command has been executed without any error. Again, the second thing is I need to execute this next command to format the specific log directory. If it is not already formatted, then it will format. Otherwise, like it will say that the logs are already formatted. It just to keep the logs and which type of format that yeah, the specific cluster ID has to be formatted. So that's the reason we need to execute this. So again, I can go back to the same terminal and execute this. So log directory is already formatted. It is being synced because I already tested this flow. Again, I'm going back. Now run Kafka server to start this command, basically this specific file to start the Kafka server, right? So we have generated the Kafka cluster ID. We have stored into some variable, and now we need to start it. So to do that, what I can do is I can simply copy this step. I can go back to the terminal and paste this command. So once I did that, so we can see that my Kafka cluster is already been started. That's the reason these many logs are there. Okay. If you are also getting the same logs, then you can be assured that your Kafka server has already been started. So I'm minimizing it. Let it be running like that. So now what we need to do is we need to create one topic, right, folks? So to do that, our topic, something called demo messages, is one of the topic that we're gonna create. And to create that, we wanna use this specific command or specific command on our terminal, right? So if you can see that basically we are trying to access this specific script or specific file, and create is a flag, and hyphen topic also one flag, and we are basically mentioning that what could be our topic name. So our topic name going to be demo hyphen messages, and also this is the bootstrap server. So basically we need to map that on which through which port our Kafka server can be run, like up and running, right? So this information need to pass. So this we are basically trying to provide port number 9092 as part of our local host, so that Kafka can use that port, right? So what we can do is simply we can again copy this specific command. We can go back to one more terminal window. So we are not just doing any more modifications in our previous window. So we have already opened one more terminal and simply paste this command over here. So once we execute this, it is saying that demo messages already exist. That means what? Because I was running this specific command previously, so my demo message already exists. That's the mean. So what you can do is we can simply change this topic name. Maybe I can say that um, cab details
topic. Let's say we are currently exposing this or creating this topic to expose certain cab online cab service information, just like we demonstrated. So for that we are creating a new topic, right? So let's see. So you can see that the topic is one topic called cap details topic is already been created. Okay. So now what could be our next step? Our next step going to be to launch our specific producer so that we can produce certain information, right? So to do that, we can take this specific command, do the copy, and we can actually go to this specific terminal, right? But here, one thing that we need to modify, that is the topic name, folks. Because topic name we modified, right? So for the time being, I will simply copy this just to ensure that we are pasting or using the same topic name. Otherwise, it will throw some error. So I can press enter. So you can see that this terminal is actually asking for some input now, right? So let it be like this. We will open one more terminal and we will do a split so that we can see that whatever messages we are being like providing through here, so that as a consumer also we are getting the same messages, right? So to do that, again, we will go to the document and you can see that I have already mentioned that uh, to start the consumer, we need to execute this or need to run this specific .sh file. So what we can do is we can simply copy this same command and open one more fresh terminal and put it over here. Again, we need to make sure that our topic name has to be the same. So what I will do is just to be make sure, I will go back to my producer window. I will copy the whatever the topic name we have provided. I will again go back to the consumer window and paste it like this. Okay. Now what I will do is we'll just try to just adjust the specific terminal so that we can see the output. So basic idea is like we will try to produce, we will try to put some messages over here from this specific here from this producer window. And if we are being able to consume the messages from this terminal, then we could say that our Kafka instance is actually working and producer and consumer both are managed well. Okay. So let me just run this command. Okay, so my consumer has been initiated. Now let me just try hi. If you see that whenever I'm pasting whenever I have provided a message called hi, automatically the same message is showing up in this window. Now if I say that cab speed maybe 25 kimi, same information we are getting, right? Now we can say that location is like uh, Karnataka, and we can also say that fare maybe 120 rupees, right? So now we can see that our Kafka instance is actually working, right? So this is how we can actually see it, where we can actually test that how exactly the Kafka works and how producer and consumer are being executed via Kafka cluster, right? So as I said, like I will provide this GitHub document. You can go through this and also you can test this Kafka in your local host. Next, we will see that how we can implement this Kafka client library programmatically, right? So yes, so that's all for this. Now we will try to implement the Kafka programmatically, and to do that, we are basically going to implement with the help of Java, right? So as part of our dependency file, you can see that the dependency specifically we are using to communicate with the Kafka, that is called Kafka-client. Okay, you can go directly to the Maven repository and look for this specific dependency as well. Now, as to just speed up this process, I already have created two specific packages where we will try to write couple of classes. So one is like handler and one is helper. But before getting to the actual code, we also need certain configurations to be done, and those configuration has to be placed into the some property file. Okay, so if I do that, if I open this file, then you can see that there are a couple of properties that I have already mentioned. So the first one is the location of the Kafka server. So if you remember, like we need a specific location to be provided where Kafka server can be started, right? And we are defining that localhost 9092 because currently we are running on the localhost. Second thing, there is a group ID that we need to provide. As we see that group is a default thing if we are not providing. So one group that we are defining, that is called test-group. The third thing is like make Kafka track, make Kafka keep track of record released by the consumer. So whenever the producer producer messages and one consumer is subscribed to some topic, so like consumers are keep on reading out those messages, right? So that is called like commits. So we need to enable one of the property called commit. If we mark as true, then what Kafka will do is Kafka will keep the track of the messages whatever the consumer is reading out. And these are the specific classes as part of the serializing and deserializing messages. We need to just enable it. Okay, so you can just have a look, and those are like both of the classes as the part of serializer and deserializer. So as we mentioned previously, that Kafka is basically whatever the messages are being produced by the producer. Those messages are being stored in the form of key and value pair. That's the reason we need to serialize key and value both, and we need to deserialize key and value both. So folks, this value always going to be the common for your case also. So that's the reason you just can have a check, and you can just grab the same value for your implementation as well. Lastly, auto offset reset equal to earlier. So if you remember that we discussed about the offset values, right? So offset are basically providing us the flexibility so that we can track or we can get a specific message out of the log or the whatever the local or whatever the memory log that messages are being stored. So there is couple of value. So we have mentioned like earliest. Earliest means whatever the message are being logged into the memory log, the newest, the earliest message, we need to read that, we need to fetch that. Okay, or we need to consume that. That's the reason it is like mentioned as like earliest. All right, so our property file is done. So now what we can do is we can create one property handler so that we can access this. So here we will simply create one class and we will name it like property helper. Okay, so property helper going to be our class. So first of all, what we will be doing is like we will be creating one public static method, and this method going to return the properties, and we will name it is like get properties. Okay, get properties going to be our method name. And at the very first line of this, we will try to define one object or the reference variable, but initially we will not assign any value to it. We will make it as null. Then we will start some exception handling, that is in the try catch block. And after doing this, after try catch block, we will try to catch any IO exception which can be which can be there probably, and if that is something happened, we will simply try to uh, print on the console. Now as part of the try, we will take the help of input stream. Okay, we try to help of input stream with the object we can create as in like input, and after that we will try to provide the path of our config.properties, right? So in the handler we can create one class that is maybe producer, right? Why I'm creating this class now? Because with the help of this class reference only, we will say that our config.properties is present, right? So that's the reason I can say that producer dot class dot get class loader, get class loader dot get resource at stream, and here we can provide one name as like config.properties. Okay, so this is done. So we are basically taking the config.property file reference with the helper producer class, because this is the something the same, the parent folder is same. Okay, and we are trying to access the resource folder of this. After line number this, the line number 15, on the next line, what we can do is we can actually assign the property value. So we can say that prop equal to new properties. Prop equal to new properties. That is done. Okay. Now one check we will provide, that if my prop is null, so what I can do is, then we can say that throw one exception. Sorry, my bad, it should be like input. So basically what I'm trying to do is, like, if my this line going to get me the value as null, that means property file is not been available or something, then what I can do is I can simply try to throw a new exception, and I can say that unable to read config dot properties, and else, so we need to just add a, so as it is throwing the exception, we can say that throws exception. Okay, and if the input file is present, that means there is no such exception occurred, then we can simply say that proc dot load, and it should be like input, right? And once all the things has been done, we can simply return to proc. Make sense? So property helper basically one exposing one specific method, static and public static method, and this method responsibility to check if the property is present. If the property is present, whatever the components or value, the key value pair we mentioned, this instance of the property, it will going to provide to us, and from wherever we require, we can directly call out that. Okay. So after that, we need to implement our producer. So before implementing the producer code base, probably we can also create consumer class, because going forward we may require it, right? And that's it. For the time being, we will only deal these three files. And finally, whatever the like main method code we are trying to do, that is something we will try to execute from the application class. So now it is the time for the producer class implement. Okay, now this is the time to implement this consumer. So while implementing the consumer code base, what we will do is we will create a logger, so that we can log our specific step informations and all those things. So logger factory dot get logger, and our class name is dot class. Okay, so quickly import this, right? So this is done. So once this is done, what we can do is we can create one method called public void method called produce messages. Okay, produces messages is one of the method that we have created, and this method responsibility to produce the messages. So to just to be more clarity, what we will do is we'll also try to comment our steps, that what exactly the steps we are following here. So this step number one, what is the purpose of it? So here we will create a producer and connect to the cluster, connect to the cluster. So this is something we will do. And also the subset of it is like, we will try to get the connection, we will try to get the connection data from config dot properties file. Basically, whatever the configuration we made as part of the configured property, those information we may require to create the producer. Makes sense? So to access the property file, what we can do is we can create one instance of the properties file. So I can say that properties equal to property helper dot get properties. So it's going to throw some exception because we already mentioned that over there. And now the major part, we have something called Kafka producer, and this is actually taking the value as key and value pair. Sorry, my bad. So it should be like string, and I can say the name can be like Kafka producer, and this should be initialized as this. So here it's basically asking for some parameter, and the parameter should be the properties. So basically through this, right? So this is a class which is basically implemented. So if you get into this, you can see that Kafka producer basically a class which implementing one interface called producer, and this class is actually having a key and value pair that we need to provide. Okay, and this is also having a specific, you see that Kafka producer, and it is asking for some property, right? It is asking for some property. So that's the reason we need to pass the property instance with it, so that whatever the configuration we made as part of the configured property file, that can be passed through this while creating the producer, Kafka producer. Make sense? Now the next step, what we're gonna do is we will create a topic. You need to create a topic. So for this case, topic can be like topic name. What can be my topic name? So my topic name can be like a same topic name we can use like cap details. This is my topic name. Now the next step is step number 3, that we need to create the message, right? Because producer created, topic also created. Now producer need to produce certain messages. For the time being, we are basically hard coding all the messages, and to do that we gonna use, so we can see that create messages. Okay, the step. And now we will take the help of JSON object, and we will name it as like messages, and equal to new JSON object. We will initialize that. Now messages dot put, because JSON object also like it is basically use the key value combo. So first message we can say that cab, or only the speed. Okay, so speed is like 25 km per hour. Okay, now I will simply copy this line so that I can create couple of more messages. So second can be like driver name we can provide something like Robert. Third is like location, so this location can be Karnataka. Then it is like something called fare we can say 120 piece, something like this. And and probably we can also say that cab type. So the cab type can be like sedan. Relatable, right? Makes sense. So we have already created our messages. Now step number 4. What could be my step number 4? Now we need to package the message in the record. So folks, so far we have created the producer instance, we have created a topic instance, we have already created what exactly the message we are trying to produce to the producer. Now whatever the messages we have created, we need to package it. Okay, and so that ultimately we send the specific messages via Kafka cluster. So to do that, there is a, so I can say that package the messages in the record. Okay. So to do that, we need to use producer record. Okay. We need to use producer record. Again, it is taking two things. Key should be string, value should be again string, and the name, object name, we can say like record, and this time we can simply pass equal to new producer record, and this producer record is actually contain three properties, three or two properties, okay. So at least two properties we need to pass. So here we need to pass is like one to our topic, because otherwise how producer would know that through which topic the message has to be recorded or the message has to be sent. And second thing is like messages, we will pass this message in the form of JSON string. Okay. So messages we already recorded. Now the final step is there. That is like we need to finally send the message. Okay, we need to finally send the message to the Kafka cluster. So step number 5 can be send the record. I would say for more understanding, send the record to cluster. Send the records to cluster. So to do that, we have already created the Kafka producer object here. So Kafka producer dot send, Kafka producer dot send, and here folks we will actually use one approach, that is like we will use the callback functions, because why we should use that, because if we use that then it would be easier to handle the errors. Okay, so to do that we need to define this specific send method like this. We need to pass record, and we also would like to call a new callback like this. So basically it is providing that one specific interface that if is going to be completed. So what exactly our purpose that we are trying to do? Our purpose is like if our exception, so if you can see this on completion method is actually providing two things. One is like record metadata, one is like exception. That means if my action, the action is like send, if this is completed, that means my send, whatever I wanted to do, that is like I wanted to send the specific message into the Kafka cluster, that is succeeded. If not, then exception will occur. So we can simply, very simple way, handling is happen here only. So very simple way we can check that if our exception instance is itself null, that means what, my message is successful, my message sending is successful. And if it is not, then we will simply print the error exception or whatever it is on the console. Okay, so that's the reason we will put a check that if e is nothing but our exception, equal to null, then we will say that we will take the help of logger this time, and we will say that sent successfully, sent successfully. Okay, that means our message has been sent successfully. And what exactly the message we have sent, that is something we need to know, or we need to print over the console. So we can say that whatever the messages we have in the format of JSON string we would like to see. And if error or exception happened, then we will try to do the paint stack trace, and probably we can also put it as a part of error message here over the console, just for better um, like uh, better log or maintaining the log, right? So once it is done folks, our producer already created the messages, recorded, and it is finally packaged and sent via this Kafka producer.send method. And what we can do is we can just put some weight here. so the wait can be like 1000 milliseconds. So just one notable thing over here, that in production we just may need to try to avoid this kind of thread or sleep, but as this is something that we are using right now in our local instance, and just to avoid that local instance having couple of foundations in terms of memory and the speed. So just to handle that, just to handle the like delay in between the producer emitting the message and consumer consume that, we are using it. Okay. And finally we can say that Kafka producer dot flush and Kafka producer dot close. So basically we are saying that our all the things happened here, all the things, if anything like either exception or successfully sent happened properly, finally we're gonna wait for some time, 1 millisecond, 1000 milliseconds, and after that we will simply try to close the Kafka producer instance whatever we have created. Okay, so this is our consumer that we just created here, right? Next what we will do is uh, okay, all right. Okay, so folks, I just made one small mistake. I haven't like seen it before, but after writing the code, I have seen that my file name was different. So I have actually written the producer code into the consumer file. So please don't get confused. I already renamed it. That is already fixed. So basically, we have implemented the producer so far. Okay, and now we are going to implement the consumer. Okay, so just rectify that if you have already have seen. So whatever the code we have previously written, that is for producer, and now we are going to implement the code for the consumer. So as part of the consumer, again the same thing, we will try to initiate a logger. So here we can say that logger dot get log factory. So it should be like logger factory dot. Let me just take it from the previous instance because this is common. So here we will simply change it to consumer. The logger is there. Okay, fine. And now we will simply create one more method over here. So public void, and we will say that consume messages. Okay, so consume message is going to be one method, and this method going to help us to consume the messages. Similar approach again we will follow. Here also we will try to document the step. So first step going to be like create the consumer and connect to the cluster. Makes sense? First we are going to create the consumer instance, and then we will try to connect the cluster. So to do that, here again properties we are going to need. So again properties equal to property helper dot get properties. Again it will throw some exception that needs to be handled, and finally we are going to define the try, and within the try the specific class which can help us to communicate or to connect with the Kafka cluster, that is like Kafka consumer. Here also we are going to have is that try and then Kafka consumer, and we have string comma string, we can say consumer, and now new Kafka consumer, which is basically taking the properties, and the body is actually started, and finally we are going to catch certain or probably this may not required as well. Probably. Okay, so yeah, so this is the what, like first try, and then we are basically creating the instance of Kafka consumer like this. So once it is done, we will get into this block, and the second step we will try to initiate. So my second step can be that we need to subscribe the consumer with a specific topic, folks. Right? Subscribe means basically consumer says to the topic that, hey topic, I'm going to like get the information from you, and topic also have the idea that okay, this is one of my consumer where I need to provide the data. Okay, so I will simply write like subscribe to topic. Here also we will simply go to the producer class, and whatever the topic we had already defined here, we will simply define here as well, so that we are on sync. And finally, whatever the consumer instance we have created, we just need to call out this and write subscribe, and the subscribe within that we need to say collections dot singleton and then topic. Okay, so topics are basically goes into the part of in the form of collection dot singleton. So that's the reason we are converting it, and finally subscribe with the specific topic, whatever we have defined as part of the producer class. Now, the next step, that is step number 3, can be like we need to poll and process the records, you can say, right? So basically poll is an type of an API as part of the Kafka. So what does it mean? Like say see producers are something which are like keep on producing the informations, right? And Kafka cluster as in consumer, the consumer has to look into the data, has to look into the updates always. So as part of the poll, we can actually define a specific timeline that okay, at which time interval I just wanted to get the updates from my cluster. Okay, say for example, I wanted to update in the 100 millisecond, per 100 millisecond I would like to get the updates, something like that. Okay, so here we will keep on checking into the cluster that whether there is any message or not. That's the reason we will try to create an infinite while loop, and here we will try to write or implement this like we will basically implement the logic where we will try to see that whether new messages are there or not. So pull new records. So to pull the new records, there is a consumer, we need to call out consumer records. So just be make sure there is two class, one is like consumer records and consumer record. We need to initiate consumer records, and consumer records also key can be a string, value can be a string. Again we can make it as like records, and we can say that consumer dot poll, and now we need to specify the duration. So duration of milliseconds, that is like 100. We have already imported the specific this one as well, the specific consumer records class as well. Now what we will do is we will process the data. In terms of process the data means, for the time being we will just wanted to see that whatever the information that our consumer consuming, we just wanted to print it. Okay, so to do that we will take the help of a for loop, and what we will do is we will say that consumer record means only one record at a time. This is like string, and I can say each record, it should be like it should be looks into the whatever the records that we're gonna have, and whenever there is a record, we will try to print this. Okay, so we will simply try to print this. So from this record we can actually print couple of things. So first of all, we can actually would like to see that through which topic our records are being consumed. So first we can just uh, print the specific topic name. Secondly, we can specifically get the specific message key. We can say that message key separately. So message key, right? Third, we can also get the value. And also get the value, right? Now we can just directly say that each record dot topic, comma, each record dot key, comma, each record dot value. Okay, so our for loop is ended here, and just to be handle all the delays and all those things, we just wanted to put 1000 millisecond thread sleep over here. Okay, so this is the implementation of our consumer folks. So basically, what if I try to reiterate? So basically here we are again trying to get the property instance, whatever we have defined. Here we are basically trying to get or trying to create the instance of Kafka consumer, because this is the class which can help us to create the consumer class based on the properties that we have defined. Now here we are subscribing with the topic, the same topic whatever you have created as part of the producer. Now here simply we have written a logic which will keep on checking the record within the topic in the duration of 100 milliseconds, basically polling concept. And finally, whenever this consumer records going to have some value through the consumer, basically through the topic, we are just trying to process means we are basically trying to print the specific records, especially three type of information, that is topic, key and value on the console, right? So this is the consumer implementation. The next implementation going to be the application. So this is, say for example, this is our actual consumer. This is the end user through which the records are going to be consumed. So this is the main class we will now implementing, and finally we will execute this specific main method only in terms of testing our implementation. Okay, so now let's implement this. So as part of the main method, first we will just try to create, or we will try to store one error message. What is the purpose of the error message? We will understand. The error message, we will say that error need to define the first parameter is producer or consumer. Probably I can say that you need to define. So folks, basically what exactly we are trying to do here is, so we are going to use these arguments string array, uh, so that we can provide one flexibility to our user who gonna use the specific or going to execute the specific application, so that they can execute and they can provide value on runtime. Okay, so basically the process is like we are going to expect one of the value, either it could be producer or consumer. So based on the user specified value, the specific method or specific code going to be executed. Okay, so first we will try to put one check, that if my args dot length at least not equal to 1, because we are expecting at least one value, like one value at least should be there. If this is something happened, we are basically trying to print some error message, and error message can be the same error message whatever we have documented, and we will simply return from the specific method. We don't want user probably get into the further steps. If all args are looks fine, the length is like equal 1, then what we can do is we can create like string mode, and here basically we are trying to get the first index value of our args array, and we will trying to create one switch statement. So you will say that mode dot to lowercase local dot root. Okay, this is the two lowercase, and if we got that the value based, and now we will put the case. If my specific mode going to be like producer, then we will simply print some message on the console that starting the producer new line, and here where we have created our producer, the producer class. So we will simply say that new producer dot produce messages, and as it is throwing some exceptions, so we can also like mention as part of the throws exception. And once it is done, we will simply call the break, and next should be the next case should be for the consumer, and here also we can simply take similar kind of message on the console, just it is going to be consumer, and now it can be like new consumer dot consume message, and if this is done, then simply break the statement, and for the default case we will again say that no such parameters, or probably we can say the error message will be the same error message we can reuse like this. Okay, makes sense folks? So this is our application class which gonna help us to execute and see that how our implementation actually working. And one thing as part of the pom.xml that I have already added as part of this segment, you can see we are basically using the build plugins, and as part of the exec maven plugin that we are using, um, basically what is the purpose of it, that whenever you are trying to execute any java or any java main class from maven, right, so we need to pass couple of parameters over there with the help of exec plugin. So there is a prohibition that we can actually mark the specific class name here as well. So something like word g, and then if we have example dot application, because if you see that this is our specific location, right, org dot example, and here we have one class called application which is we have just called out, so that whenever we execute or compile this maven pom.xml, we do not need to explicitly mention that where our main method is actually located. And how we can check that this class is actually being referring the same application or not, if we simply try to like control and click, so it will take you to the specific class itself. That means your class whatever wherever you have mentioned this main method, that is being mapped here successfully. All right, so next we will try to launch the terminal, whatever however we have seen as part of the local instance executing, and then from there we will see that we will trigger the maven command, and we will try to see that whether our respective implementation of Kafka and producer consumer working or not. So before going ahead with our execution, we need to start the Kafka cluster. Okay,
And to in terms of starting the Kafka cluster, this time we're gonna use the Docker container for Kafka, right? So this is the project currently, if you see in my GitHub repo, and this is I have already mentioned all the required commands that you're supposed to execute in terms of like launching the Docker instance of Kafka, and also how you can exactly pass the runtime environment for the program and execute, right? You can check out this. So what I'm gonna do is like I'm gonna take or copy this specific command to execute the Docker image of Kafka, and then we will start executing and see how producer and consumer are being working, right? So to do that, as I am working on the Windows, so I will open the Windows PowerShell. So for the time being, if I just wanted to see what are the containers are being executing, so if I can see that there is no such container or image being currently running in my system, right? If I simply close it and I just copied the specific command, whatever I have mentioned on the GitHub README file, that same thing. And if I hit the enter and just wait for some time to be executed, so you can see that my Kafka cluster is actually started. Very well. Now just minimize this. Now I would like to open my first terminal, and you can see that the path of the project is like where I have the specific project there. So I already navigated to this path. Okay. So here for our help and for our reference, we can also refer the same command here, right? This is the command that we need to execute in terms of launching our producer. Okay. So just before launching the producer, I just wanted to remind you that we are basically going to produce this kind of information. So if you close this, yeah, this kind of information like scab information. Okay. So if I go back to the terminal and try to just paste the command, whatever we have, we are basically trying to launch the producer now. You see the producer, my producer already started, and if you see that very carefully, folks, so this is the information that we have actually passing, correct? If we try to match it, like my fare and the speed and the driver name and the location, so the order can be random, but if you see that the ultimate value is something that we are printing in the form of JSON, that is something producer already produced. That means if I go back and again try to launch one more new window, this is I'm considering as part of my consumer. So let it be like this. Say for example, this is my producer, resize the window, and this is my consumer. I'm resizing the window. And this time if I just paste the same command, but this time instead of producer, I will try to write consumer, what will happen? So my code started, and this time if you see my consumer is keep on running, because remember that we have actually used the while infinite loop, and each time, right, each time it is 100 millisecond it is trying to pull the records. So here if we try to see a bit more, as it is keep on pulling the record, so probably I can search here something like messages. And yes, this is the messages that we are actually getting. What is that message? Yes, this is the message, right? The topic is like capitals, we do not have any such key defined, and this is the value that currently we are getting as part of the producer, right? Yeah, this is the value. So value is like fare, this one, and this the location is like Karnataka, and speed is this. So this is the same information whatever we are getting from our producer, right? From whatever they're getting from the producer, the same information we are being able to consume as part of the consumer as well. Now we just implemented only one message, right? So if you want, you can actually improvise, and we can actually create many more messages like that. So moreover, if we just create some random method which can generate the random string, you can keep on passing that. Producer keep on produce that information, and what will happen, like
consumer will keep on getting the information and try to print over the console. Okay, so that's all as part of the implementation of consumer and producer within Kafka cluster using Java and Kafka client library. I hope this helps to you to understand overall the Kafka implementation. And you can probably check out the GitHub page also, my GitHub project also. There I have actually segregated this entire project in couple of more application and more class has been introduced on the specific project, because this is a very basic structure that we have implemented to see how we can do that, the base level of it. But a bit more advanced level has already been implemented and hosted on the GitHub, right? Thanks for watching.